Hey everybody! This video is to help us work some solutions for problem 2.13.20 in collaborative statistics. This involves BMW 3 Series, 5 Series, and 7 Series cars, and in particular the age of a series. Looks like 130 purchasers of 3 Series, 130 of 5, and 130 of 7 Series cars. They were asked how old they were when they purchased their first car. I'm assuming their first 3 Series, their first 5 Series, their first 7 Series. I imagine some of them could be the same in both or all 3 data sets if they move their way through or down or across the ranks of BMW ownership. So anyway, it says part A, incomplete sentences describe what the shape of each box plot implies about the distribution. Okay, well, take a look at the 3 Series. You've got lower 25%, next 25, upper 25, upper 25. Without knowing the actual individual data points, because we don't know what they are, we have a 5-number summary. You can tell there's more variability on the right side, the upper 50%, than on the left side. That means this data set is going to have an average that pulls that way, which means it's skewed. It's skewed to the right, I believe is the phrase. But it's skewed because your average is going to be pulled that way. Compare and contrast that with the BMW 7 Series, which is way more symmetric left to right. Yeah, the median's a smidge low, but infinitely more symmetric than the 3 Series data. And we'll talk more about what's probably going on, actually what guaranteed is going on in that upper 25% in the next section. 5 Series, it's fairly symmetric except the median being pulled down so far this way, and the average is not going to be pulled via outliers anywhere near as extreme as this is, because I don't see any outliers in this data set. So as far as the distribution, it's more symmetric than your 7 Series, but less, it's less symmetric than your 7 Series, but more symmetric than your 3 Series. Skip B for now, we'll come back to B next time. Compare the 3 box plots. What do they imply about the age of purchasing a BMW? Well, what do you guys think? What's happening to the average? Take that back. What's happening to the median age of purchasers as we work up through the ranks? This is where I like looking at this, the middle 50% of the data. There's the middle 50% of the 3 Series, 50% of the 5 Series, 50% of the 7 Series. In my opinion, there's a humongous difference between the 3 Series and the 5 and 7. And there's less of a difference between the 5 and the 7. Same amount of variability, it's just a slight tick up in age for the 7 Series. I don't know if it's statistically significant or numerically significant, but there's just definitely a difference in the 3 Series. I think I have a theory about that later. It doesn't ask us why? Oh, let's ask the obvious question. Why do you think that is? And you'd have to know something about BMWs to know this. Think about that, we'll come back to it. Look at the 5 Series. Which quarter has the smallest spread? What is that spread? Okay, well here's the 5 Series. There's your smallest spread. Looks like it's somewhere between 37 grand, sorry, not 37 grand, that's 37 years. Somewhere between 37 years and it looks like about 42, so about 5-year spread there. Next part is what's the largest spread over the 5 Series? Looks like the next quarter. So roughly 42 to 57. So what's that? That's going to be 15 years. 5 Series, find the interquartile range. So that's going to be between those extremes. So 37 to 57, roughly 20 years. Are there more data in the interval 31 to 38? Let's mark that. We're still looking at 5 Series now. 31 to 38. So here's 31, I'm guessing. 31 to 38. I think they've just given us the values here. Or the interval 45 to 55. Yeah, I think they just gave us a little more accuracy than I had. Okay. So are there more data here or here? And this is actually very parallel, congruent, honestly, to an earlier problem. There have to be more data points from 31 to 38. There just have to be. Because 45 to 55 does not contain the entire 25% of the data set that's down here. I'm going to come back, there might be a caveat on that. This has to contain 25% of the data. By definition, it's a quarter. The only way this might contain 25%, it most likely contains less than 25%. The only way this could contain 25% would be, let's give that median a value of 42, okay? The only way this thing could contain 25% is if you go from 45 to 42, that's down 3. 42 down 3 would be 39. So 39 would be here. If all of the data in this quarter were between 38 and 39, that would mean the smallest data point up here in this quarter was 45, which would mean that all of the data in this quarter would actually be between 45 and 55. It's a very silly mathematical argument. The median would still be at 42 because it would be the average of 39 and 45, and it's such a convoluted example it feels silly to even talk about it. But mathematically it could be. It doesn't have to have less data. It just most likely does. Look at the 5 series again. Which interval has the fewest data? 31 through 35, which would be here. Let's do this. This is getting really colorful. That range. 38 to 41, which I'm guessing is this one. 41 to 64. I'm guessing that's basically all the way out. Well, okay, we can eliminate this. 41 through 64 is the top 50% of the data. So that doesn't have the fewest data points. That has the most of those 3 ranges. This guy here, excuse me, that's 25% of the data. And this, using the same argument we just used in letter G, has to have most likely less data. We could probably set up a similar argument that says it could have equal, but it's even less likely, I think. So, the range 31 through 35 most likely has the fewest data points in it. If you assume a uniform distribution of ages, which with that many ages is getting pretty close to realistic, I would think, it's even more believable. Hope that helped.